It's my oh man, thanks God. Okay, all right. Smartphone was fall down, but I catch in the air, and it's not my magic. God help. This was the supernatural help God provided me. And first of all, I want to clear this concept. I am working macro, so we cannot use gloves. I have multiple types of gloves, but in this I cannot use, and I cannot make this project. And for what purpose I am making this DC to DC isolated power supply? Before this live stream, I try to repair this expert VM 1.2 kilowatt solar hybrid inverter, but I not found a true voltages for this HCPL 3150. Okay, so finally I decide I need to make isolated power supply from DC to DC from battery voltages. Here we need to have uh, minimum 12.5 to 14 volts required for this auto coupler, and after that they can provide the PWM to this MOSFET to charge the battery from solar energy. So we need to make DC to DC isolated power supply in this live stream. This is the modulator UC3845. This modulator can provide you a 50% duty cycle and 500 kilohertz frequency. Okay, and we need to run our transformer on 35 kilohertz. So first of all, this is the modulator name UC3845, and our project name isolated power supply from 9 volt to 16.5 volt DC. Okay, first of all I need to check this modulator. Okay, and we need to wind a transformer especially for this one winding primary winding, second winding for auxiliary, and third is the secondary winding. Okay, first of all, here we have pin 1 2 3 4 5. So set your multimeter on continuity mode and keep the positive on pin 5, because here we have GND pin 5, and keep the negative on pin 8. First of all, we need to have the internal resistance of this modulator. Okay, we have true resistance for this modulator, and after that you need to keep again the positive on pin 5, and here we need to have some internal resistance. Okay, here we have 0.646, and after that you need to keep the negative on pin 8 and check this pin number 6. We need to have more than resistance. Okay, but here we have no any continuity. Oh sorry, the pin number 7, I was thinking about the HCPL 31. So this is the pin 7 VCC and pin 5 GND. First of all, we need to have internal resistance of this pin 0.60. It's okay, and Now we need to have internal resistance from NPN transistor. I'm talking about block diagram. And after that we need to keep the negative on pin 7, and here we need to have more than resistance from negative, and we have, it's okay, with multimeter measurement. So let's get started. First of all, how we can check in the real time our PWM modulator. Okay, we need to have some components. One, non-polarized capacitor depending on your output frequency. Second, resistor or RT, resistor timing, and power supply. And we need to connect one resistor for more purpose to I-sense pin. I am talking about pin number 3. So let's get started. Okay, here I am using 10 nanofarad non-polarized capacitor. Where are you? Non-polarized 10 nanofarad. Okay, I found. We have 1 non-polarized, okay, 10 nanofarad capacitor, non-polarized. You can use a deep package, and here we can use the formula of ferrite core transformer. Okay, step by step we are talking about this. Okay, I am turning on my old smartphone because I have the application in this smartphone to measure the RT and CT, resistor timing and capacitor time app. Okay, and before this, sorry for gloves because this is the macro work and I cannot work with gloves for this. And I need to hold the components with hot glue temporary, and when I receive the true voltages, my required voltages, after that I need to provide here a toast glue. We can call glue or we can call epoxy, it's okay. First of all, pin number 5. First I need to talk about the pin configuration. Pin 1 feedback pin, pin 2 compensation pin, pin 3 I sense pin for current limiting, and we have pin number 4 RTCT, resistor timing and capacitor timing, and pin number 5 we have G and D, and pin number 6 we have a PWM output, pulse wide modulation output pin, and pin number 7 VCC to run this modulator for operating, and pin number 8 we have VREP voltage reference to provide here to RTCT pin. It's okay, 5.1 voltages, and you can operate this modulator from 8 volts to 35 volts, but the required and recommended voltages is 12 to 14 voltages. MK4 Asilbek said hi. Thank you. The hard thing, we have two hard things. First of all, I am running this power supply from battery, so First provide here uh, voltages to get out PWM, and after that we will try to run this with some resistor for single pulse, and after that we need to wind the auxiliary winding in this transformer, and I need to remove this winding. I need to get another empty core and bobbin. Okay, first of all we are starting from G and D pin number 5, and after that we need to provide for iSense resistor negative, and keep in mind you need to provide with star configuration. Okay, we are talking and we are working on this, but first of all we need to get output PWM from this modulator. So here I am working for this. For star configuration I need to cut the wires with some length to connect with pin number 5. I was done this projects in 2021, and now I need to run this circuit and solar hybrid inverter because the MPPT solar charge controller are not working in this inverter, and it's hard to know about 100 types of solar charge controller and solar hybrid inverters. Okay, sorry for bad soldering. Little I need to increase my temperature of my soldering station. Okay, 360. It's okay. Cut the extra. It's okay. And first I need to provide little hard glue, and this is the best thing for projects like this. Here I cut little glue, little hard glue, and I need to here provide some hot air to hold this. It's okay, that little wet for this. Now connect the negative with pin 5, and I have approximately 2 hours more because the time is here 9:30 p.m. and if I will not done, we will done tomorrow if God will. Okay, little wet required for hot glue, but we can join this. It's okay. Now the one important component is that non-polarized capacitor to create frequency. Okay, and the value is that this component is 10 nanofarad non-polarized capacitor. Okay, set the position again. Here we have pin 1, okay, on left side, pin 1, it's okay. Now we need to provide, oh man, the wire length is very high, so our modulator is not setting here because the hot glue is not perfectly dry. It's okay. Solder pin number 4. Okay, and provide here a little solder for best soldering. It's okay. And now connect here with this bit. Now provide negative to this 10 nanofarad capacitor. Another side, okay, I am cutting here. It's okay. And now how we can easily remove the plastic from this. That's okay. Good. And now we can tie the solder. It's okay. Sorry about shaking. It's okay. Now connect this. This is the capacitor. Oh man, little hard working to make like this. Okay, I have sharp tweezer. I need hold this PCB for little time. So here I am providing a hot glue little to hold this PCB for me. I have already on bottom side the UC3 at 4.5 with feedback, but I decide to share with friends to learn. Okay, now our PCB is okay. Little weight required or glue, but it's okay. It's okay. It's done. Another one. Okay. First we need to calculate the frequency. I decide I need to run my transformer on 35 kilohertz. Okay, I need to. Okay. Here we have power transformer calculator. Okay, and here we have TL431, and we need to find okay UC3 at 42, UC3 at 43, UC3 at 44, UC3 at 45 calculator. UC3 at 42 and UC3 at 43, you can get the output frequency 500 kilohertz, and you can get from these two numbers UC3 at 42 and UC3 at 43 99% duty cycles, and you can get from UC3 at 44 and UC3 at 45 50% duty cycle. So I am using UC3 at 45. It's okay. Here I have already data for capacitor, so I need to put here 10 nanofarad. First check, you need to put the value in nanofarad. So I have 10 NF nanofarad. It's okay. And now what about Here we have a frequency focus, a capacitor, resistor. Okay, we need to the resistor. For example, here I install in the real time 10 nanofarad, and I need to get output frequency 35 kilohertz. Okay, you need to put in kilohertz. Little I need to zoom out my, it's okay. I need to put the frequency 35 kilohertz. I need to run my transformer. So here I need to uh, install 2.46 kilo ohm resistor. Okay, and first I need to check I have this resistor or not in my sample book. Okay, I have 1206 size SMD resistor sample book. Okay, uh, uh, 2.46 kilo ohm. Okay, 10 R. Oh, we are in the ohm, not in kilo ohm. It's okay. 150 ohm, 510. Okay, 1k 6, 2k, 2.2k, and 2k 4, 2.4k. Okay, I have 2.4k. It's okay. So I need to get here one resistor from this. Okay. Now, it's okay. This is our RT. It's okay. I need to connect this with you need to connect this with pin number 8 voltage reference. Okay, voltage reference. It's okay. This is the pin 8 and pin 1, 4, 5, 6, 7, 8. Okay. Solder. It's okay. And flexible. I have flexible wire, but without insulation, because I have not thin wire with isolation, so I am using here without insulation because the resistor size is small. We cannot use here hard wire. Okay, bend this. Little I need to provide more area, and it's okay. And I need to connect this with pin number 4 RTCD. So why not bend here? And after that, bend here. It's okay. Cut. Solder and join. It's okay. Little I need to set this. No man, it's okay. All right. Wow. Further. Okay. This is our RT and this is our CT. Now I sense required resistor 2 kilo ohm. Or 2.7. Some people are using 2.7 and some are using 2 kilo ohm. So here I am using 2 kilo ohm for iSense. 2 kilo ohm resistor. It's okay. Pin 3. This is our pin 3. Okay. Connect this with pin 3. Set. It's okay. My soldering station. Okay. I set on 320 because it's okay. Now I need to provide negative. Here we have negative, so we can easily provide negative to this resistor for iSense. It's okay. I have oscilloscope and we can check output frequency. It's okay. iSense resistor provided, CT provided, and RT provided, and one thing more required to provide here a compensation. Compensation you can provide from negative or feedback. First you need to provide compensation data or voltages. It's okay. It's okay. Solder. Okay, compensation pin. Our pin number 2 is compensation. Man, why you are not setting little bend? Set this. Make a degree with fingers, man. Oh, it's hard. Okay. It's okay. It's done. Okay, now feedback. We can provide a feedback to pin 1 with pin 2 with a PC at 17 auto coupler. but first we need to get output PWM. In this time I need to have red color wire. Okay, I have per VCC, apply here. It's okay. And this is our VCC pin. Pin number 7 is our VCC. It's okay. Now I need to provide first 12 volts with my bench power supply. Check the output PWM. Okay, and for measuring the PWM I need to connect this white color wire. It's okay. Pin number 6 is output, and I need to connect this. It's okay. This is our output PWM. Okay, now I am providing around 12 volts with my variable bench power supply. Okay, okay, 13 point some voltage. Okay, you can provide from 8 volts to, oh, my crocodile clamp. Not good for this little wires. It's okay. Now I am providing voltages. Okay, this is the positive. I have fluke kit, but for saving the time I have everything in this fluke kit. Okay, but save the time. Okay. You can check without oscilloscope your PWM modulator providing the frequency with duty cycles or not. So our pin number 5 is G and D, so I need to keep the negative prop. Little I am sitting here, a negative with pin 5, and I need to keep here the positive on pin 6, and we need to have 6 point some voltages are more than 5.3. So the meaning is that we have output frequency and duty cycles in square wave. Let's check with oscilloscope. This is my kidding oscilloscope, and I have 30 megahertz Hitachi. For big projects, it's okay. Now check. Okay, I'm searching for probes. Okay, here I have a probe to install it and check the output frequency. So I connect the white color wire for PWM output, and already we have pin number 5 black color wire for GND, so I'm connecting with this, and now I need to connect this with the G and D ground, so I'm connecting this with negative. And just check, I need to zoom in. with care. uh, so now I need to winding on 32.5 kilohertz. Okay, now we are receiving, and you can adjust this frequency from this resistor. You need to install here potentiometer if you want to increase and decrease your output frequency, how much frequency required for you. So on this resistor, remove this fixed resistor and install here 10 kilo ohm potentiometer. Connect the center pin and pin 1 or pin 3 and other pin just like this, variable resistor, and you can call potentiometer like this. This is the potentiometer, and you can adjust your output frequency from this potentiometer. Just one side connect with the pin number 8 voltage reference pin, and another side connect with the pin 4 RD resistor timing, and you can adjust your output frequency. Now first of all, now I need to receive little frequency, little pulses with some resistors power supply, because we cannot provide like this because we have not the fixed voltages power supply. And another side, I think I have a negative, but after that we need to provide here a power feedback PC817 already isolated autocoupler, and if we connect the negative and positive from power supply in this inverter, so let's play with this. Why I am upgrading from this to start little pulses with some resistors. I have some resistors here in dip packages. 1 kilo ohm. Okay, I'm searching for 1 kilo ohm, 0.25 watts. I have here 1 kilo ohm. Where are you? 1 kilo ohm. Okay, thank you, man. Little dip package resistors I have. One and another Mr. Padre statue. Where are you, brother? Okay, 2 resistor I am using here. Okay, now the mission is that we need to get little pulses for first time, start the transformer, and after that we can provide auxiliary input to this modulator to run continuously with good performance like that. Okay. So first of all, here I need to provide this 1 kilo ohm resistors with positive. So I am making a series. So now this is the 2 kilo ohm. Okay, and now connect this wire with this side. It's okay, and connect here this positive to receive little pulses. I think. Okay. Oh no, man, no, man, no. It's okay. the required voltages. Okay, check the voltages on pin 5 and pin 7. How much voltages we have? Zoom out. It's okay. Let it show your multimeter. Negative and positive. How much we have? 7.4. Not enough to run this modulator. So here I need to cut one. I am providing this positive. We are not receiving the output. Any voltages are PWM with resistor. 7.62. What about? No, we are not receiving the pulse wide modulation. I think the resistor size is not enough because we are receiving a direct power supply. Now how much voltages I apply? Okay, let's check on GND and VCC 13. Okay, decrease this voltages. How much? 10.48. Okay, more decrease. Okay, how much? 9.2, I think. Yeah, more little decrease. This appear. Okay, the minimum voltage is 9. Okay, now 8.7 approximately. Yeah, 8.7. So we need to provide here a little big size resistor. And here I have in this dip package PCB. Dip package is component PCB 1.5 kilo ohm. I am removing the component. The resistor here. .5 kilo ohm, 1 watt, I think. Okay, connect this now. We are not receiving any PWM with 1 kilo ohm, 0.25 watts, quarter of watt. Okay, now I need to connect this 1 watt or 0.5 watt. I am not sure because I am not using dip packages component after a long time. It's okay. Now check. 1.5. Okay, already we have 9 point. No, any PWM we have. Okay, little increase the voltages. Wow, no any PWM output. With resistor in ohms. What is this, man? Okay, in solar hybrid inverters we have 1206 size and 200 kilo ohm, and we are receiving the output first. Then what issue we have in this? Okay, I'm thinking about. Now I need to connect 680 ohms and 2 watts. Yeah, man. I think this is the 2 watt. Okay, now connect here first. Okay, we are receiving with this resistor, but the voltage is high, 15.1 degrees. We are not receiving the voltages. Diodes and capacitor. Okay, one more thing. I need to install here a capacitor, little wet. I'm searching for capacitor 220 UF. No, little small size, 220. Yes, okay, this is good. 220. Oh, let's do the magic with this. How? Just check, and I need to again play with this small resistors. How? I need to connect the capacitor negative with negative. Okay, I'm soldering here temporary to just record. That's okay in live stream. And now I need to connect this positive here. Okay, and this is our modulator positive, and now I need to connect this modulator positive here on this capacitor. Okay, connect here. Now apply the voltages on this side. No any response. Okay, apply here. Okay, what about the voltages on pin 5? Oh yes, man, this is the thing now. Okay, we provided with 1 kilo ohm. Now the magic is here. Okay, now install here in little wet. Good, with 2 kilo ohm. Oh man, this is the capacitor magic. Okay, and now I want to add one more 1 kilo ohm resistor to make 3 kilo ohm total resistance for this modulator. This is the important thing, the first pulse. You can get output auxiliary voltages from transformer to run your modulator continuously with auxiliary winding. Okay, so now I am installing one more resistor of 1 kilo ohm here. 1 kilo ohm. Where are you, man? Where are you? 1 kilo ohm, 1 kilo ohm. I have a lot of boxes, so okay, one more resistor of 1 kilo ohm. Okay, but what about now? I provide 12 volts, and if I provide here 9 volts, Okay, let's little wait for response of this modulator. It's okay. We are receiving the pulses. Okay, now I am connecting one more resistor with this. It's okay. Now provide power. We have little pin. Ah, I can solder my crocodile beam already damaged and solar hybrid and motor connectors. Nothing. That's okay. Solder does not matter, man. This is your property. It's okay. Wait for a capacitor. Wow. Now the capacitor, when the capacitor stored the charges with 8.7 voltages, after that the modulator are consuming the power and providing the PWM pulse wide modulation on pin 6. And when the PWM modulator start the work, the capacitor again empty and the modulator in the under voltage is lockup mode. And again when the capacitor charge 8.5 something voltages and the modulator are starting again. So this is the magic of capacitor here. It's okay. We can run our first pulse with 3 kilo ohm resistance. Now how we can count the formula to measure this center area. This is the high frequency peroid core transformer. I already winded this on for some purpose, so I have, if I have more transformer and bobbins. Okay. This is my transformers property, and here I have core, yes, and this is the bobbin. So let's remove. I wind this with screwdriver head. Okay, remove this winding because we need to wind this with formula. What about the PWM output? Okay, we are receiving. Okay, cut this. Cut here. Okay, remove this. Another winding. I have a lot of winding in this transformer. Cut. Let's wind a transformer in this live stream and check the formula. The hard thing for me, auxiliary voltage is, but oh, we are playing. Never give up, because this is the possible thing to provide auxiliary power modulator. So I am removing the previous windings. How much winding I have in this? I winded this, and now I order ready-made transformers. I am just replacing. It's okay, cut this winding. Okay, one more. Okay, I think this is the primary. Yeah, finished. It's okay. One more winding we have. This is the last winding. Wow, one more. Ah, cut this. Okay, need to clean here. Okay, first I need to remove this wire with soldering iron. Here, one, two, I'm just removing the previous winding wires from pins, but here, because there we have oscilloscope and modulator and live components, so here I am just removing the extra wires from pins. Okay, I clean all the fins here. One, okay, I need to clean this one. It's okay. And now, first up, we need to measure the center core area in centimeters, because here we have formula and centimeters. Okay, finally we have centimeters. So what about, where is my vernier caliper, man? Now I can wind this in this size core. Set here now with care. Wow, that's a lot of high frequency transformer cores. Now I know about my this size core, but oh, dust. Okay, I clean. this, I need to know about my this center. First I need to measure this side, and after that I need to this side, and I need to calculate in square centimeters. We have 5 centimeters, but we need to measure this. Need to have the measurement tool in centimeters, the good tool, and how about very that size here. It's very long, man. Here we have centimeters. If we have here millimeters, after that we can calculate. Oh, we have not 1 millimeter, and I'm searching. I hope a shopkeeper or school babies. I need to just search measurement tool for this, and after that I can wind my transformer with this formula. So here I use this check. This is your nominal voltages in DC, like this is for SMPS from 260, from 180 to 260. So this is the main formula, and this is the frequency, and I forget the name, and the transformer depending on quality core, depending on your core. So I need to learn again this, but first of all I need to have the measurement tool. In my workshop I have not what's the time, 10:23. On something I have in millimeter or not, I'm just thinking about first. Millimeter. 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 1 mm, 2 mm, 3 mm. Okay, I'm closing my workshop. I'm coming again in 5 to 10 minutes to purchase the measuring tool for this core. Okay, I am lucky. Finally I found a complete set, but this is not for engineers. This is for school boys. And woohoo, we have millimeters in this, and this is the transparent. We can measure. Okay, how? To multiply width and length. Okay, this is millimeter. 10 millimeter is equal to 1 centimeter. Okay, and 100 centimeter is equal to 1 meter. Now I need to measure. Why? Oh, charge. Provide charge to smartphone, man. Quick, quick. Okay. A smartphone provide me a charge. Then I am shutting down. That's okay. Okay. Charge provided. Now this is the millimeter. So we need to know about first our width. 1, 2, 3, 4. 4 mm. Okay. 4 mm by no count. You can count from this side, but if you know about some mechanical data. Okay, 4 and 5. Okay, we need to multiply. Okay, smartphone to calculate 4 mm and 5 mm. We have lengths. Okay, 0.4 multiply by 0.5. Wow. 0.2 centimeter. We have core center area. 0.2. So here we need to use here. This is my favorite core, so I need to 0.2 centimeter. Okay, and we have 32.5 kilohertz frequency. So here we need to write. Okay, I'll put the value. And what about input voltages? So here we have 297 per 220 volts SMPS power supply to make DC voltages from AC. So here you need to count the nominal voltages. Our battery nominal voltages is 12, and the minimal is 9, and the maximal is 15. So we need to add here 12 volts. Okay, start brackets. Remember the formula. We have 12 volts, 12. Okay, again multiply 10 to the power 8. How much zeros we have in this, because I am very weak in maths. 1, 2, 3, 4, 5, 6, 7, 8. Yes, 10 to the power 8 or 1 to the power 8. What is this? I am not expert of maths, and this is the reason I write. Okay, voltages. Okay, nominal voltages multiply. Okay, a 10 and 1 and add 0. Okay, 1 2 3 4 5 6 7 8. I have not the science calculator, so close the bracket and divide. Again start the bracket. Okay, and 4 is formula. 4 multiply by, here we have 70 kilohertz frequency, and now I am designing this on 32.5 kilohertz. So here I need to put 32.5 kilohertz. Yes, okay, let's 32. Okay, cut 1 32, and you need to count in hertz. Yeah, okay, here you need to write in hertz like 70 kilohertz. So I write here 70,000 hertz. So here I need to put 32,000 hertz. Again multiply 1800. Okay, and again multiply by with the core center, core section area. So here I have 0.2 centimeter, 0.2, and close the bracket. Okay, so this is our primary turns. 26 turns required for primary winding. Okay, take a screenshot, or again take one screenshot from this. Okay, I already mentioned everything from start to now. Okay, 26. So how much turns we have per 1 volt? That's rough. Today I sent calculation about solar panels. Okay, zoom out. We have 12 volts and we have 26 turns. So divide 26 divide by, okay, 26, remember, and again 26 divide by 12. So 2.166. Okay, just 3. Okay, 2.166. Okay, 2.166 turn per 1 volt. Okay, now we are receiving again the 12.5 volts. So multiply 2.1. Okay, multiply by 12.5. So we need to again wind with 27 turns to receive 12.5 volts again. Okay, isolated. Why I am making this? Just for isolation, to isolate this voltages. Okay, and this is the fixed output. We can provide later feedback. If you are providing 9 volts, you can get 12.5 volts, and if you are providing 16.5 volts. You can get fixed voltages with the help of feedback and compensation pin. Okay, the 26 primary turns and 27 secondary. Now what about auxiliary? We need to provide a 12.5 volts auxiliary, so 2.166 per 1 voltages. So again 26 turns to receive auxiliary voltages. That's okay, and we can use a Zener diode and a 10 ohm resistor for auxiliary fixed voltages. So our primary turns 26, our secondary 27, and our auxiliary is 27. Okay, this is our turns. So now remove how we can wind this. I am providing a little gift, but we need to modify this machine of winding this transformer. Okay, remove this everything. Little I need to set here. Okay, but first I need to disconnect or decrease more my power supply. Okay, I decrease. Disconnect all the power first. 26, 27, and 27. It's okay, desolder, man. Don't think about safety. We are playing from 2004 with this soldering iron, and we need to follow the safety, but in some wars we cannot use safety because this is not the dangerous thing. It's just the lovely things electronics in my life. Okay, it'll just okay. Now we can remove, and for removing this thing I am providing one more idea that you are working. So yeah, no man, okay. Cool. Okay. This is our modulator. It's okay. Keep this carefully. We need to use this later, and we need to use MOSFET, N-channel MOSFET, to run the transformer. It's okay. Now just check my winding machine. Wind some turns. Winding machine, where are you? Oh, pound. Oh, a lot of dust. Oh man, I was make a winding machine for this thing, but I take the lithium cell. Okay, what about the lithium cell? Why I remove all the wires? I need to check this lithium cell. Negative. Oh, 2.960 voltages. Then why I select? Ah man. Ah, working, but the button was not good, so the button is damaged per clock and anti-clockwise. So now we need to just use this machine with my bench power supply. I need to set this on 3 to 4 volts, and for low speed, and I need to count the turns, and I can count. Ah, Very smooth speed, man. And I need to, okay, anti-clockwise. I need to wind on clockwise. It's okay. Decrease the speed. This speed is good. Okay. And now this is all bobbin. Okay. Yeah. Good. It's okay. No. It's good. Wire. Two types. So this is good. Okay. Captain Tap, Caesar. Captain Tap. Caesar, Caesar, Caesar. Okay. Okay. This is our primary and auxiliary. So remember one thing, if you are winding, so you need to start here like this. Okay, and we can cut later, just I need to think about on this. Okay, and you need to complete the turn. If you are starting from here like this, for example, do not this, and you cannot complete your complete turn, because when you start from here, you can connect this wire with this, so this is not the complete turn. So you need to start from here. Okay, start from here, and now just check how we can wire. Now I can count the turn to again come this area. Just check. Okay, to get wire. That's okay. One. Okay, little tight this bobbin. Okay, one, two. No, man. I need to remove the tap. Okay, and cut this wire. Okay, nib. Little, I need to zoom this. Okay, little. Wow. Caesar. Oh no, Caesar not. Nib. Nib. Where are you? Nib. Sharp nib. Oh man. Okay, here. Little I need to take care because I am using nib. But my other hand is very on the distance. Safety is more important for these tools like scissor, nib and grinder and sharp things. It's okay. Again. Now count and wind. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. It's okay. 18. Now little tap required. 18. But we cannot use this formula because our turn is at 26. So 18 and 18, 36. Oh, I need to wind. This is not good thing. You complete this bobbin from here to here, and from here to here you are ending your winding. This is not a good thing. So what we need to do with this thing, I remember why the manufacturer are using this little tab, because this is the basics working the transformer, but not good thing, man. And I need to just wind 13 and one and 13 and another, are 26 with thin wire in one layer. So we count. Okay, reverse the polarity. 25, 24, 23, 22, 21, 20, 19, 18, 18, 17, 16. What is this? 16? Oh man. And now remove complete the winding. So here I need to make one layer with 13 turns. How possible? And now reverse the polarity to motor. Read that on clockwise. Okay, so I need to start from here. Yes, 13 required. One. Okay, 1, 2, 3. Oh man, 3. Okay. 1, 2, 3. Okay. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. It's okay. And now right there. The XLRS and not the quality Captain tab. I'm cutting with Fluke. Fluke is not good, but does not matter here. No man. Okay, 13. So now I am setting this tab. Okay, 14. I need to cut this extra. Okay. This thing is not good. It's okay. $15, 16, 17, 18, 19, 20, 19, 20, okay? 21, 22, 23, 24, 25, 26. It's okay. This is the primary. Little reverse, little. I need to work on this machine. It's okay. Here I need to isolate this. From this wire. It's okay. And here I need to turn all this. So here I need to provide tap, little pepper tap, because when I'm using this we can short or winding. So here I need to provide little tap. How possible? Okay. Now we can. Okay, cut this here. Primary. First primary. Again, this is just for counting the turn. And this is the start. You can use here negative, positive. Okay, this is our primary. And just paper tab better from this Captain tab, because the Captain tab quality is not good. I purchased online. This tab is better than from Captain tab for winding. Okay, I'm cutting with Fluke. It's okay. Now the secondary. It's okay. Primary, secondary. It's okay. Start from this. Okay. And again, I need to draw this. One, okay, 2, 3, 4, 5, tight little, 5, it's okay, 5, 6, 7, 8, 9, 10, 11, 12, 13, okay, 13. Oh, we cannot 13.5, we can 14 or 13, so let's 14, okay, 14, 14, 18, it's okay, 14, 15, so 14, it's okay, 14. But before, you need to install here isolation. How? Like this, cut the paper, okay, and you need to, some people are working in little fingers, but you have big, so you need to use here a tab with tweezer. Cut. Okay. Now, oh, I do mistake. I need to write here completely because I need to write 18 turns, 28 turns. Okay. Cut extra. Okay. 14, 15, okay, 15, 16, 17, 18, 19, 20, 21, 22, Anna man, 23, 24, okay, set little this time, 24, 24, 25, 26, 27, 28, it's okay. right here, wire, one turn and cut. Okay, now what about auxiliary? Okay, this is start winding and start and okay, now just wind the auxiliary. Okay. Oh, you have space or not, man? What about the bobbin? I did not think about the bobbin. It's okay. Auxiliary winding. It's okay. Or auxiliary. If I have, what about core? How much area we have more? Core. We have little more area, 2 layers, but little doubtful. So I need to use thin wire, and this is good thing to use thin wire for auxiliary. Uh, I'm searching for a little thin wire if I have. Thin wire. Oh man. How much? Okay. How much area we have in this bobbin now to wind the auxiliary, because we need to wind in 2 layers. Little area we have, and we have 2 layers. No, we cannot use this wire for auxiliary. I need to search thin wire. Another rule I have, but this is thick from this. So, and transformers are in relays. I think in relays we have thin wires. I think here I have power wire. And one another method for transformer winding. If you have hobbies, you can use this wire. Okay, twist with a drill machine and flexible thick wire, approximately 16 AWG in flexible shape. Okay, another side I have. Wow, I'm lucky. 2021 year rule I found. 4 years later I found. Okay, and for 28 turns I need to cut this and separate one thin wire. Okay, this is thin and we can use this for auxiliary, but we need to separate carefully. Broken. Now, okay, first I need to untwist, and after that I can get a true wire. So how we can untwist? Okay, you can untwist with like this again and again, holding some cloth or some paper. Do this process and you can untwist. It's okay, I think I'm able. What is this? Okay, I'm separating. I separate. Oh, wind, very bad weather yesterday and today. Okay, now I need to just put this. Okay, auxiliary. So need to use this pin, and we can complete this at 28 turns, I hope. Okay, so I need to start from here. Okay, no, do not touch with another windings. It's okay. Two. Okay, tight this. Three. Tight the bobbin first. Three. Oh man. Three. It's okay. Four. Five. Six. I think. Not good winding. Six. I forget, man. I need to start again and start from another area. Okay. Decount. Now count again and start from here. Yeah. Straight. Do not sleep, man. Do not sleep. It's okay too. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 14. Okay. After 14, paper required. After 14, 14, no man. 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. It's okay. Finished. Okay. This is our transformer, and finally, for good view, I need to provide captain tab. I am cutting the captain tab for this size. The good captain tab quality is not good. Fake sellers. First time I receive bad quality in captain tab. Oh man, not good quality tab. Is this the tab or just a plastic with little glue? Okay. This is our transformer. It's okay, and this is the starting pins, and this is the end. Start, end, start, end, and start, end. We will decide later. In flyback technology, you need to use same winding per negative or per positive. We can know about later, because I know about this is my starting point. I start from here and end this winding on this pin. Again I started from this pin and end this, and we can know about from consumption. We can use this start point for positive output or input, or for negative output or input. We can decide, and we can know about when we will apply a voltages with frequency and with duty cycle. Okay, let us zoom out. This is my winding machine, and you can find a pulses, and I need to install starter to start with food. Yeah man, but we can wind with one hand, and we can use our one hand to just provide pulses. This transformer are working like this, pulses, okay, with duty cycle. And what is duty cycle? Okay, I am providing more data about PWM, because this video is related with pulse wide modulation. Okay, now you need to provide here little more tab, but not kept on tab, because The Captain tab is not good. One. We can provide varnish later. Okay, first we need to get output voltages from this transformer. Okay, now a little more tape required. To tight this temporary, it's okay. And now we can use this transformer, but before using this I need to mark here because I need to cut the extra wires from this transformer. So this is our start winding, so I need to write here start from this pin S, okay, and S for this, and for this auxiliary S. Now the shortcut of ending the winding E for this, okay, and E for this. And what about start and start and okay, this E I need to use for both. So this is doubly upside down. This E is using for this ending end point, and when you are reading the S, this E is using for this. Okay, man. Now cut how you can solder, man. Huh. Okay, I am providing more data. Don't worry about this little talks. Okay, zoom in. Wow. Set your soldering iron or soldering station on 480 degrees centigrades and touch the soldering station tip with this copper wire without insulation. Here we have a point of copper without enamel wire, okay, and you can solder this like this. Just check right here, 480. Oh man, I need to hold this, okay, little bit, because I need to keep this on bench because I have no surface area. This is the winding machine, and I need to zoom this. Okay, now good. Now I'm using a 180 watt soldering because we can burn our isolation. So just solder. It's okay. Solder. Another. This operation is required quickly do not provide heat for a long time. I am not using this transformer in PCB, so I am not taking care to set the wires. I need to use like this prototype, and this is my first auxiliary winding. Before this I not use auxiliary because I had also a 12-volt power supply in my projects, and this is my first project. I am using auxiliary output to operate the UC3845. Okay, now check the continuity. Oh man, I'm just holding my multimeter. Oh, the weather is very bad, and I need to just check this continuity, and after that, friends, tomorrow, if God will, I need to complete this project and install in this solar hybrid inverter. I start from solar hybrid inverter, and in the middle I stuck to repair the power supply to A3150 because we have 100 types of solar charge controller and we cannot remember. The life is too short, so we need to use our own formulas for repairing. Okay, for example, here I write S. What about S? Okay, S. This is start and end, one winding. It's okay. Again, this S. What is this? Okay, this two pin is not connected. Okay, now this S start, and this is the end point. Okay, we have soldering plugs on pins. Just check continuity. That's okay. Another start and end point. That's okay. Okay, and now we need to use just the N channel MOSFET, but check 11:28 p.m. and the weather I need to show you. And tomorrow in the night time, like from 7 p.m. to 11 p.m. we need to use this SMPS isolated power supply from 9 volt to 16.5. Okay, this is my promise. I'm keeping this. I'm not a liar. You can check my previous live streams. And after that I need to install this power supply in this inverter, and I need to run the solar section of this inverter. Let us check. I am not working on little projects, but this is the required to work on this. I need to use this power supply in this inverter because I checked everything, but this is the topology to make the power supply on little transistors. Okay, some persons can repair, but I can not repair because we have multiple types. Like this is the NVRX Voltronic board solar charge controller, and this is the Growatt SPF 3000 TL HVM charge controller. Another side we have a lot of multiple types of solar charge controller. So I am not responsible to learn a whole life just about solar charge controller. I learn push pull or half bridge topology, and after that you need to learn flyback transformer working topology, and after that you need to learn the DC to AC converting section and simulated sine wave technology. Otherwise, this is just wasting of time to learning. You learn now, and when you look another in 2026, complete system change. So I am not wasting my time on solar charge controller more. I already spent approximately 4, 3 to 4 hours, I think, 4 to 5 hours I spent, and I lost my time. And finally, I decide why not provide here a isolated power supply to run this autocoupler and repair this inverter with my technology. And after that, we will discuss. I have software easy EDA, and I can design everything like this. I have already approved Furqan. I designed this. This is the UC3843 for my projects and with feedback. But I not use this. Why? I use this to provide my data because the people are searching for UC3845 PWM. So this is the special thing for my friends. Okay, gift from Mad Expert, and accept this gift. And now the time is over, so I am keeping here. I need to just turn off all the lithium batteries and solar hybrid inverters, and after that I need to go in home and just check the outside weather. I am repairing also the lithium batteries and solar hybrid inverter, and this was the bench. One day ago I cleaned this bench, but the weather and na 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 na. Just check. I am the one mad person who are working in this workshop. Otherwise, the world is sleeping. Okay, take care. See you next time tomorrow, if God will, with this beautiful work. Thank you. Take care.